The year was 1962. In a small English town, a 10-year-old boy wandered into a library to escape the rain. His wet shoes squeaked on the wooden floor as he strolled through the aisles, eventually finding himself in the mathematics section. There, amidst the quiet hum of the library, a single book caught his eye. Its title was The Last Problem. Inside the book was a single equation, deceptively simple. Though only 10 years old, the boy could understand the equation, but the words accompanying it sparked something within him. This problem has remained unsolved for 300 years. As he closed the book, his mind raced. He thought, I will solve this problem. Like King Arthur discovering Excalibur, this moment marked the beginning. The problem that captivated young Andrew Wiles was first proposed 3 centuries earlier by French magistrate and amateur mathematician Pierre de Fermat. While Fermat spent his days presiding over courtrooms, he devoted his nights to mathematics. His constant companion was a book called Arithmetica, whose margins became his canvas for mathematical musings. In one such margin, Fermat penned what would become his most famous challenge. Inspired by Pythagoras' theorem, Fermat proposed a radical generalization. He claimed that for powers greater than 2, there were no whole number solutions. Then, tantalizingly, he wrote, I have discovered a truly marvelous proof of this proposition, but the margin is too narrow to contain it. This cryptic note became the most famous mathematical enigma in history. Like a treasure map, Fermat's claim lured mathematicians into a centuries-long quest. Was his proof real, or was it a bluff no one knew?
Technomics.
In the 18th century, the torch passed to Leonhard Euler, one of history's greatest mathematicians. Despite losing his eyesight, this prolific genius continued his work, attempting to solve Fermat's last theorem using only his mind. To address the case of Schill, Euler introduced a revolutionary concept: imaginary numbers. At the time, the idea of numbers whose square was negative seemed absurd. Yet Euler saw their potential and defined them as, using this mathematical imagination, he proved Fermat's theorem for. However, when he tried to extend his solution to so, Euler fell short. His partial success marked an important milestone, but left the theorem tantalizingly unsolved. Euler's work resembled a daring explorer reaching Everest's foothills, but unable to summit. Nevertheless, his efforts blazed a trail for future mathematicians. The 19th century introduced a new hero in the story, Sophie Germain. In an era when women were barred from academic pursuits, she corresponded with leading mathematicians under a male pseudonym. Her contributions were groundbreaking. Using auxiliary primes, Germain developed novel techniques for tackling Fermat's theorem. She proved the theorem for numerous cases involving prime exponents, though like Euler, she couldn't extend her findings to all numbers. Her life embodied quiet rebellion, a testament to perseverance and brilliance against overwhelming odds. Though Fermat's last theorem remained unsolved, her work inspired generations of mathematicians. By the mid-20th century, mathematics had transformed. Enter Taniyama-Shimura, Shimura 2 Japanese mathematicians who proposed a revolutionary idea. Every elliptic curve is modular. Their conjecture bridged 2 seemingly unrelated mathematical realms: elliptic curves, which describe geometric shapes. Andrew Wiles never forgot his childhood promise. In 1986, he discovered the connection between Fermat's last theorem and the Taniyama-Shimura conjecture. He realized that proving this conjecture could finally solve the 300-year-old puzzle. Working in secret for 7 years, Wiles immersed himself in equations and proofs. Often late into the night, he cycled between moments of breakthrough and despair. In 1994, Wiles emerged to present his proof at Cambridge University. Before a packed hall of mathematicians from around the world, he spent explaining his monumental achievement. As he wrote the final line on the chalkboard, he turned to the audience and said simply, "I think I'll stop here." The room erupted in applause. Fermat's last theorem was finally solved. Fermat's last theorem represents more than a mathematical puzzle. It stands as a testament to human curiosity and persistence.
The first rule of channel is subscribe channel. Second rule of channel is click like. This channel will make you smart.